The power set is a special set, and this set contains all the subsets of a set. So let's just take a set C and say that it contains a 5 and a 9. So that's set C. Well, the power set, and the way we do this is we use a capital P, and then in parentheses we put the set. So the power set of C equals the set that contains all the subsets. So there's the empty set, because we know the empty set is a subset of every set. So that's one element. Then there's the elements that are a set with a single value. So here's the set with the element 5 and the set with the element 9. And then there's the set with the two elements, so 5 and 9. So that is all the sets, all the subsets of C, and that's the power set. Now let's do one that has more. Okay, so let's say we have a set that has 3. So it has 3, 8, and 2 as the elements. What would be the power set of this one? Well, the way we would write it was with a capital P, and then in parentheses put the set, and it equals all the subsets. So a set that contains all the subsets. So the empty set, and then all the sets with what I like to do them in order because it helps me keep track of them. So I'll do all the sets with only one element, and that's 3 and 8 and 2. And then all the subsets with 2 elements, and that would be 3 and 8 and 3 and 2. Notice that these get big pretty fast, right? And 8 and 2. Now, what about the set 2 and 8? Remember that the set 2 and 8 is exactly equal to the set 8 and 2 because order doesn't matter in sets. So the only sets of 2 that we have are these 3. And even though we could do other order ones, they're equivalent, so they wouldn't be listed. And then, so we've got all the ones with 2 elements. Let's go ahead and put the one with 3 elements. And this one will be that has all of them. All right, so there's the power set of D. So notice how these get exponentially bigger. And we can talk about that by identifying the cardinality. So if we look at the cardinality of the power set of C, right, what is the cardinality of that? Notice that it has 4 elements. And if we look at the power set of D, right, if we look at the power set of D, how many elements does it have? If we count all of the elements, it has 8 elements. And we can double check that we've got all the elements in a power set by identifying that the cardinality of any power set, right, the power set of any set is related to the number of elements. And it equals 2 to the power of the number of elements that it has. So 2 raised to n. Let's put this as a superscript. Where n is, if n is the number of elements in the set, or the cardinality of the set, right? So in the set S. So where n is the number of elements in the set S, then the cardinality is 2 to the n. So in this case, notice that C has a cardinality of 2. So if you take 2 and raise it to 2, you get 4. In this case, D has a cardinality of 3. So you take 2 to the power of 3 and you get 8. And if you have a set with 4 elements, then it's going to have 16 elements in the power set. And so you can see how this grows exponentially, the power set. So the power set is the set of all subsets of a given set.